In this tutorial, we are going to talk about machine learning interview questions. But wait, what is machine learning? So machine learning is a technique to understand and to train your model using some data. The companies like Ola, Uber, Google, and every company who are like right now booming, they are using machine learning techniques because of its flexibility, and also it's actually help you to understand your business, your data, and using those data you can make your model as well, right? So keep that in our mind. We came up with a tutorial where we are going to help you if you want to prepare for your interview in machine learning, right? So we have almost 100 questions to understand what are the main questions you should prepare when you go for any interview, right? So before start the tutorial, let me introduce that Great Learning has came up with a brilliant idea, that is Great Learning Academy, where you will get almost 80 plus free courses, and after complete your course, you can claim your certificate as well. And if you want to do this course in your mobile application, that is also possible using Great Learning app. So let's get started with the tutorial. In this tutorial, we are going to talk about machine learning interview questions. But let's have a look at what we are going to learn in this tutorial. First, we are going to look at why do we need machine learning. So let me give you an example. Why do we need machine learning? In the past, we used to have a data in a structured format. Now, as the volume of the data is increasing, so the number of structured data becomes very less. So to handle the massive amount of data, we need some data science techniques, right? And those data can be used to get the proper business insights and the hidden trends from them. But wait, how can I use those data science techniques, and how can I make my model, right? And why these data are in a massive amount? Let me give you an example. Suppose you are booking your cab, or you are just booking your food, right? So every time you are doing an online transaction or an online booking, you are making the data without knowing it, right? So whatever the booking you are doing, all the respective companies rather using your data, and they are saving your data. But why? Because they want to focus their business. They want to understand which product is most popular and which one is getting the more popularity, and what will be their upcoming forecasting for the sales, right? So for all these things, they want to check from your data, and you are giving those important data to those companies, right? So this is why they are actually storing those data. But wait, those data are not in a structured format, right? Those data are in a unstructured or a semi-structured format. So this is why the company is trying to use a technique or a mechanism that will help them to use those data. And machine learning is one of them. So when you have those data, and after cleaning those data, making those structured data, you can make your own model. And from that model, you can try to predict your upcoming sales forecasting, or the upcoming maybe the important order, or maybe the important or most liked orders, right? So this is why we are using machine learning. Basically, these techniques are giving us the insights from the huge chunks of data which are in a very unstructured or a very, without any structured format. And it also helps to reduce the production cost, as well as you can make your own model which can actually help you to predict your data without any human interactions, right? So this is why we need machine learning. Now we are going to look at what is machine learning. So machine learning is a subset of artificial intelligence. We all knew about this term, what is artificial intelligence. So yes, in artificial intelligence, there is a subset called machine learning that allows the system to automatically learn and improve from experience without being explicitly programmed. But what does that stands for, right? So when you give a data to your model will learn from those data. After that, you don't need to do anything. Just need to give your new data to your model, and your model will work for you. So basically, this model will work as a human to predict whatever your objective is, right? Suppose you are giving a data for a credit card fraud analysis. So in that case, if you want to check which transaction is a fraud transaction, you can make a model using the past data. And from there, from all the parameters, your model is going to say, okay, this transaction is a fraud transaction, right? So you don't need a human to finding out that, right? Now we are going to understand what is the model building, what is the steps you need to follow when you are going to make your first machine learning project. Let me give you the example. What will be your life cycle stages? First, you need to understand the business problem. When you understand the business problem, the first objective, why do we need to use this model? Why do we need to make a model, right? So this will be your business problem. Suppose let me give you an example. You are going to make a model on credit card fraud analysis. So basically you have an objective to find the fraud transaction. So this will be your business objective. Then you need to go for data acquisition. So what is data acquisition? So data acquisition is basically collecting your data from any dump, from anywhere. You first need to collect the data. If you don't have enough data, how can you understand and how can you make your model more perfect, right? So second stage is collecting the data. And the third stage is you need to clean those unstructured or semi-structured data. So cleaning process is very hectic. But if you clean your data, you can start building your model, right? So cleaning process is quite time consuming. It's quite hectic as well. But yes, you can clean your data from those semi-structured data. From those chunks of data, you can make your solid data. From there, when you have done the data cleaning part, when your data is in a structured format, you can go for using exploratory data analysis. But what is EDA? EDA is basically a statistical concepts we use to understand our data. Your data is clean. Now you need to understand what is the range of your data, how your data is going to behave. It's a continuous data or a discrete data. So all the cases you can understand by using exploratory data analysis. And when you have done the exploratory analysis, data analysis, you can actually understand your data more easily. Yes, you have a good grip on your data. Now you know which machine learning algorithm is gonna work for your particular model, right? So as we know, we have three types of machine learning. We will talk about that later as well. So from those algorithms, you can understand which one will suitable for you to make your model. Then you will make your model using that particular algorithm, and you have the data, and from those data you are going to use your model to train from those data, right? And from there, when your model is trained, you need to predict your model. But wait, why do we need to predict our model? Yes, because let me give you a simple example. Why do we need to prediction for your model? So we all used to go to school, right? And our teacher used to take an examination for us as well. But they know you are actually going to school every day and you are learning from there. But why they need to take an exam for you? Yes, just to make sure whatever you are learning, that is perfect with a new type of question. So in the same case, we are going to give a new data to our model, which our model never seen before in the training phase, and we just try to figure it out how our model learns, right? So basically, predicting your model is one of the most important part. And when you see your model is ready and giving a accuracy, good accuracy with the new data as well, you can deploy your model, right? So this is the whole life cycle of a machine learning project. Now, we are going to talk about what are the most popular programming tools or programming language we have used in this machine learning and data science concepts. So we use SQL for a database. We use Informatica, Python, Java, R, SAS, and MATLAB, right? So these are the basic tools and the language I have talked about. There are lots of tools you will get when you go for using these concepts, right? Now, we are going to talk about some interview questions. But before that, let me give you an example. What is the difference between traditional modeling versus or the traditional programming versus machine learning? So if you look at the image itself, you can say, okay, for the traditional programming, every time you need to write a code. This is pathetic, right? You have to have a human interaction every time. A human needs to write a code, and according to that, you will get a output. First, you will get the data, and then you need to write a program, and then only you will get an output. But in the case of machine learning, you will get a data, you will make your model, and you will get the output. And the second time, whenever you are going to give the data, your model is ready. You don't need to program every time. Your model is ready to give you the answer. So this is why machine learning is one of the most used and most popular concepts right now, because it's reducing the human effort. It's becoming It's making our life easy basically. So this is the main difference between traditional programming versus machine learning. Now we are going to talk about few interview questions. So if you are a machine learning enthusiast or if you are an artificial enthusiast, I should suggest you to go for watching the full video, because this question is gonna help you to crack your job in machine learning or in artificial intelligence domain. So what is our first question? We are going to talk about explain the term artificial intelligence. In the short, we know AI and machine learning, that is ML and deep learning, right? So what is artificial intelligence? So artificial intelligence, which is AI, is the domain of producing intelligent machines. ML refers to system that can assimilate from experience, that is the training data. And deep learning states to systems that learn from experience on large data sets. So yes, if you want to use a deep learning technique, you need to have a large data set to train your model. And machine learning can be considered as a subset of AI. Deep learning is ML but useful to large data sets. Yes, so deep learning also comes under machine learning, but whenever you are going to use a deep learning technique, you need to make sure you have a large amount of data sets. The figure below roughly encapsulates the relation between AI, ML and deep learning. So deep learning is a subset of machine learning and both were the subsets of AI. So you can say DL and ML, which is deep learning and machine learning, both are subset of artificial intelligence. ASR, that automatic speech recognition, and NLP, that is natural language processing, falls under AI and overlay with ML, that is machine learning and deep learning, as machine learning is often utilized for NLP, that is natural language processing, and ASR tasks, that is automatic speech recognitions, right? I hope this gives you the answer. What is the difference between artificial intelligence, machine learning and deep learning? Because this is the most confusing question whenever you go for start doing your domain expertise in these domains, right? Now we are going to talk about the second question. What is that? What are the different types of learning or training models in ML, that is machine learning? Yes, this is one of the most useful and interesting question. ML algorithms can be primarily classified depending on the presence and absence of target variables. So let's have a look at what the different types of learning or training models we have in ML, right? Yes, we do have three types of machine learning. We have supervised learning, unsupervised learning, and reinforcement learning. So what is supervised learning? When you have a labeled data, what is labeled data? So suppose you have a data which is for credit card fraud analysis, right? Again, you need to find it out the fraud transaction. That time you have a features and as well as you have the class. So if you have a class, that is known as the label data. So if you have a label data, you can use any supervised learning technique. But if you don't have a label data, you have an unlabeled data set, that time you should need to go for using unsupervised learning. And in the case of reinforcement learning, I hope you all heard about Tesla self-driving car, right? So model starts learning from itself. So if your model is going to do a good job, you are going to give a rewards. And if your model is going to make a that not good decision, that time you are going to give a penalty. So this is how reinforcement learning works. So these are the main domain we have under machine learnings. Now we are going to talk about the third question. What is the difference between deep learning and machine learning, right? Machine learning involves algorithms that learn from patterns of data and then apply it to decision making. Deep learning, on the other hand, is able to learn through processing data on its own and is quite similar to the human brain, where it identifies something, analyzes it, and makes a decision. The key difference are the manner in which data is presented to the system. And machine learning algorithms always require structured data, and deep learning networks rely on layers of artificial neural networks, right? So this is the main difference between deep learning and machine learning. Now we are going to talk about the fourth question. What is the main key difference between supervised and unsupervised learning? So supervised learning technique needs label data to train the model, as we know from the last or previous question. For example, to solve a classification problem, a supervised learning tasks, right? You need to have label data to train the model and to classify the data into your labeled groups. Unsupervised learning does not need any labeled data set. This is the main key difference between supervised and unsupervised learning. Now we are going to talk about how do you select important variables while working on a data set, right? What are the most important questions? There are various means to select important variables from a data set that include the following. Identify and discard correlated variables before finalizing on important variables. The variables could be selected based on p-values from linear regression, forward, backward, and stepwise selections as well, lasso regression, random forest, and plot variable chart. Top features can be selected based on information gained for the available set of features. So these are the main techniques. If you're gonna use them, you can start selecting important variables while working on a data set to make your model, right? Now we are going to talk about how are covariance and correlation different from one and another. Covariance measures how two variables are related to each other and how one would vary with respect to changes in the other variable. If the value is positive, it means there is a direct relationship between the variables and the one would increase or decrease with an increase or decrease in the base variable respectively, given that all other conditions remain constant. Correlation quantifies the relationship between two random variables and has only three specific values, that is 1, 0 and -1. 1 denotes a positive relationship, whereas -1 denotes a negative relationship, and 0 denotes that the two variables are independent of each other. So this is how you can see how are covariance and correlations different from one and another, right? Now we are going to talk about the 7 questions. State the difference between causality and correlation. So causality applies to situation where one action says X causes an outcome say Y, whereas correlation is just relating one action X to another action Y, but X does not necessarily cause Y. So this is the main difference between causality and correlation, right? Now we are going to talk about explain one-hot encoding, the one of the most used technique in machine learning, and level encoding. How do they affect the dimensionality of the given data set? So, one-hot encoding is the representation of categorical variables as binary vectors. Level encoding is converting labels or words into numeric forms. Using one-hot encoding increase the dimensionality of the data set. Level encoding does not affect the dimensionality of the data set. One-hot encoding creates a new variable for each level in the variable, whereas in level encoding, the levels of the variable get encoded as 1 and 0. So this is the main difference between one-hot encoding and level encoding, right? If you look at the image itself, you can say food name is apple, chicken and broccoli. If it's categorical, you can say 1, 2, 3. So you will have a 3 category, that is one apple, that's fruit, chicken and broccoli. Whereas you have the calories as well. So if you do a one-hot encoding, so you can see for apple you have given 1 and for other cases you have given 0. In the case of chicken, you have given 1 to chicken and apple and broccoli is 0, 0. Whereas in the case of broccoli, again apple and chicken will be 0 and broccoli will be 1, right? Now we are going to talk about when does regularization come into play in machine learning and why do we need that even, right? At the times when the model begins to underfit or overfit, regularization becomes necessary. So what is underfit and overfit? We will talk about that as well. So it is a regression that diverts or regularizes the coefficient estimates towards 0. It reduces flexibility and discourages learning in a model to avoid the risk of overfitting. The model complexity is reduced and it becomes better at predicting, right? Now, if you look at this, for the underfitting, you can say it is too simple to explain the variance. In the case of overfitting, force fitting too good to be true. So basically, when we go about overfitting, your model will not learn. Your model start reminding the training data set. So maybe you will get a good accuracy in a training position when you are actually training your model. But in the case of testing, when your data is totally unknown to your model will start giving very bad accuracy. That means your model stop learning. It starts reminding your data set, right? So you have to be careful. Your model should not be underfitted or overfitted, right? Now we are going to talk about the 10th question. How can you relate standard deviation and variance, right? So standard deviation refers to the spread of your data from the mean, variance is the average degree to which each point differs from the mean. That is, the average of all data points. We can relate standard deviation and variance because it is the square root of the variance, right? So yes, we came to the 10th question, and yes, I also want to know how you feel about these questions and how much you can relate when you are actually working for the interview of machine learning. Please do let us know in the comment section, and let's go to the next question, right? Now we are going to look at a data set is given to you and it has missing values which spread along first standard deviation from the mean. How much of the data would remain untouched? Interesting questions, right? So how many of you knows about this? Let me give you the answer. It's given that the data is spread across mean. That is, the data is spread across an average. So we can presume that it is a normal distribution. In a normal distribution, about 68% of data lies in one or first standard deviation from averages like mean, mode or median. That means about 32% of the data remains uninfluenced by missing values, right? Now, let's have a look at, is a high variance in data good or bad? High variance directly means that the data spread is big and the feature has a variety of data. Usually, high variance in a feature is seen as not so good quality, right? Now, we are going to talk about if your data set is suffering from high variance, how would you handle it? For data sets with high variance, we could use the bagging algorithm to handle it. Bagging algorithm splits the data into subgroups with sampling replicated from random data. After the data is split, random data is used to create rules using a training algorithm. Then we use polling technique to combine all the predicted outcomes of the model. Now, we are going to talk about what is time series. A time series is a sequence of numerical data points in successive order. It tracks the movement of the chosen data points over a specified period of time and records the data point at regular intervals. Time series does not require any minimum or maximum time input. Analysts often use time series to examine data according to their specific requirement. So here, let me give you an example. Where do we need time series forecasting? We all aware about weather forecasting. So basically, weather forecasting help us to understand what can be the weather for upcoming days. Yes, in that also we are using time series forecasting concepts. There actually we are using our past data to forecast our future, right? It's very interesting topic as well. If you want, you can also check out our videos on time series forecasting, right? Now, here we are going to talk about what is a box cost transformation, right? Box cost transformation is a power transform which transforms non-normal dependent variables into normal variables as normality. Is the most common assumption made while using many statistical techniques. It has a lambda parameter which, when set to 0, implies that this transform is equivalent to log transform. So basically, it is used for variance stabilizations and also to normalize the distribution. So what is the difference between stochastic gradient descent, which is known as SGD, and gradient descent, that is GD? So gradient descent and stochastic gradient descents are the algorithm that find the set of parameters that will minimize a loss function. The difference is that in gradient descent, all training samples are evaluated for each set of parameters, while in stochastic gradient descent, only one training sample is evaluated for the set of parameters identified, right? Now, let's have a look at what is the exploding gradient descent problem while using backpropagation technique. When large error gradient descent accumulate and result in large changes in the neural network weights during training, it is called the exploding gradient descent problem. The values of weight can become so large as to overflow and the result in non-values. This makes the model unstable and the learning of the models to stall, just like the vanishing gradient problem, right? So these are the most common problem when we talk about maybe recurrent neural network. That time we are basically facing this problem, this exploding gradient descent problem and vanishing gradient problem, right? Now, we are going to talk about, can you mention some advantages and disadvantages of decision tree? Yes, obviously, the advantages of decision trees are that they're easier to interpret. are non-parametric and hence robust to outliers and have relatively few parameters to tune. On the other hand, the disadvantages is that they are prone to overfitting. Yes, you have to take care of that your model is not overfitted as well as your model is not underfitted, right? Now we are going to talk about what's a Fourier transform. Fourier transform is a mathematical technique. From the name itself, we know about that transform any function of a time to a function of frequency. Fourier transform is closely related to Fourier series. It takes any time-based pattern for input and calculate the overall cycle of state, rotation speed and strength for all possible cycles. Fourier transform is best applied to waveforms since it has a function of time and space. Once a Fourier transform applied on a waveform, it gets decomposed into a sinusoid, right? Now we are going to talk about what is marginalization. Explain the process. So, marginalization is summing the probability of a random variable x given joint probability distribution of x with other variables. It is an application of the law of total probability, where pxx equals to summation of px is equals to x comma y, right? Given the joint probability, we can use marginalization to find px equals to x. So it is to find distribution one of random variable by exhausting cases on other random variable, right? Now we are going to talk about explain the phrase curse of dimensionality. Yes, if you start working with machine learning techniques, you will face this term so many times, right? Let's have a look at what is this phrase actually wants to mean by. The curse of dimensionality refers to the situation when your data has too many features. The phrase is used to express the difficulty of using brute force or grid search to optimize a function with too many inputs. It can also refer to several other issues, like if we have more features than observation, we have a risk of overfitting the model. When we have too many features, observations become harder to cluster. Too many dimensions cause every observation in a dataset to appear equidistant from all others, and no meaningful cluster can be formed. Dimensional reduction techniques like PCA come to the rescue in such cases, right? So this is the main reason why do we say this is a curse of dimensionality when you have your data with lots of dimensionality, right? Now we are going to talk about what is the principal component analysis, that is known as PCA. So the idea here is to reduce the dimensionality of the data set by reducing the number of variables that are correlated with each other. Although the variation needs to be retained to the maximum extent, the variables are transformed into a new set of variables that are known as principal components. These species are the eigenvectors of a covariance matrix and therefore are orthogonal, right? So this is what principal component analysis, which is PCA, stands for. Now we are going to talk about what is rotation, or why is rotation of components so important in principal component analysis, which is PCA. Yes, rotation in PCA is very important as it maximizes the separation within the variance obtained by all the components, because of which interpretation of components would become easier. If the component are not rotated, components to describe variance of the components, right? So this is why we can say rotation of components is so important in PCA. Now we are going to talk about what are outliers. Mention 3 methods to deal with outliers. First, I will give you the reason and I will give you the proper idea about what is outlier, and then I will give you an example of outlier as well. So a data point that is considerably distanced from the other similar data points is known as an outlier, right? They may occur due to experimental errors or variability in measurement. They are problematic and can mislead a training process, which eventually result in no longer training time, inaccurate models and poor results, right? Before going to the 3 methods and to deal with the outlier, let me give you a practical scenario where you can understand what this outlier stands for. Suppose you have a list of data for age, right? You have a 30 to 40 range in all the ages. Suppose you got some ages which is 80 and 90 and 100. So this 80, 90, 100, the age of 80, 90, 100 will be your outlier, which are not similar with the other data points. They will work as an outlier, right? Some of the cases using outlier and making model makes no sense. But some of the cases, like for anomaly detection, you have to look at those outliers only. They will be your answer, right? Yes, so handling outliers is quite difficult and you have to understand your problem as well. So now we are going to talk about three methods to deal with outliers. First, univariate methods looks for data points having extreme values on a single variable. Then we have multivariate method looks for unusual combinations on all the variables. Then we have a Minkowski error, reduce the contributions of potential outliers in the training process, right? So these are the three ways you can handle your outliers. Now we are going to talk about what is the difference between regularizations and normalizations. Normalization adjusts the data, whereas regularization adjusts the prediction function. If your data is on very different scales, especially low to high, you would want to normalize the data. Alter each column to have compatible basic statistics. This can be helpful to make sure there is no loss of accuracy. One of the goals of model training is to identify the signal and ignore the noise if the model is given free rein to minimize error. There is a possibility of suffering from overfitting. So always be sure again your model is not overfitted and underfitted, right? Regularization imposes some control on this by providing simpler fitting functions over complex ones, right? So this is the main difference between regularizations and normalization. Now we are going to talk about explains the difference between normalization and standardization, right? So normalization and standardization are the two very popular methods used for feature scaling. Normalization refers to rescaling the values to fit into a range of 0 to 1, whereas standardization refers to rescaling data to have a mean of 0 and the standard variation of 1, that is unit variance. Normalization is useful when all parameters need to have the identical positive scale. However, the outliers from the dataset are lost. Hence, standardization is recommended for most applications. Now, we are going to talk about how do we check the normality of a dataset or a feature. Visually, we can check it using plots. There is a list of normality checks. They are as follows, like Safiro, right? Anderson, Martinez, Kolmogorov, and D'Agostino's Cunis test, right? See, all are the tests we can do to check the normality of a data set or a features. Now, we are going to talk about differentiate between regression and classification, one of the most asked questions. So, regression and classification are categorized under the same umbrella of supervised machine learning. The main difference between them is that output variable in the regression is numerical or continuous. Wait, what is continuous value? Suppose your weight, your height, right? 82.1, 32.4, right? This is your continuous value. While for classification, it is categorical or distinct. Wait, let me give you the example of categorical or distinct. Maybe based on the features, your transaction is a fraud transaction or your transaction is a genuine transaction. So your output will vary between 0 to 1. These data sets are known as categorical or discrete. Example, to predict the definite temperature of a place is regression problem, whereas predicting whether the day will be sunny or cloudy or there will be rain is a case of classification, right? So these are the reason and these are the difference between regression and classification. This is very basic, but you have to be very sure you have proper idea about regression and classification. Now we are going to talk about list all assumptions for data to be made before starting with linear regression. Before starting linear regression, the assumptions to be made are as follows, like linear relationship, multivariate normality, no or little multicollinearity, no autocorrelation, and homoscedasticity, right? So these are the assumptions we took before we start with linear regression. Now we are going to talk about when does the linear regression line stop rotating or finds an optimal spot where it is fitted on data. A place where the highest squared value is found is the place where the line comes to the rest. R squares represent the amount of variance captured by the virtual linear regression line with respect to the total variance captured by the data set, right? Now, we are going to talk about why is logistic regression a type of classification technique, not a regression. Name the function it is derived from. Since the target column is categorical, it uses linear regression to create an odd function that is wrapped with a log function to use regression as a classifier. Hence, it is a type of classification technique and not a regression. It is derived from cost function, right? Now, we are going to talk about what could be the issue when the beta value for a certain variable varies way too much in each subset, when regression is run on different subset of the given dataset. Variations in the beta values in every subset implies that the dataset is heterogeneous. To overcome this problem, we can use a different model for each of the cluster subset of the dataset or use a non-parametric model such as decision tree. Now, we are going to talk about what does the term variance inflation factor mean. So basically, variation inflation factor, which is known as VIF, is the ratio of variance of the model to the variance of the model with only one independent variable. So VIF gives the estimate of volume of multicollinearity in a set of many regression variables. And VIF equals to variance of model with one independent variable, right? Now, we are going to talk about which machine learning algorithm is known as the lazy learner and why it's called so. KNN is a machine learning algorithm known as a lazy learner. KNN is a lazy learner because it does not learn any machine learned values or variables from the training data, but dynamically calculates distance every time it wants to classify. Hence, memorizes the training dataset instead, right? So this is how, and this is the reason why KNN is called as the lazy learner. Now we are going to talk about, is it possible to use KNN for image processing? Yes, it is possible to use KNN for image processing. It can be done by converting the three-dimensional image into a single-dimensional vector and using the same as input to KNN. So normally we use image processing for deep learning like convolutional neural network or regional convolutional neural network, but as well as you can use KNN as well. As long you can use a convolutional neural network and flattening your data to 1D array, and then you can use KNN. As simple as that. Now we are going to talk about differentiate between k-means and KNN algorithms. This is the most confusing part. When I start my journey with machine learning, oh my god, every time I used to get confused with these two terms. So let me tell you what is the differentiate between k-means and KNN algorithm. KNN is a supervised learning, whereas k-means is a unsupervised learning. With KNN, we predict the level of the unidentified element based on its nearest neighbor and further extended its approach for solving classification or regression-based problems. KNN is unsupervised learning, whereas we don't have any labels present. In other words, no target variables, and thus we try to cluster the data based upon their coordinates and try to establish the nature of the cluster based on the elements filter for that cluster. Right? So this is the difference between k-mean and KNN algorithm. Now we are going to talk about how does the SVM algorithm deal with self-learning. SVM has a learning rate and expansion rate which take care of this. The learning rate compensates or penalizes the hyperplanes for making all the wrong moves, and expansion rate deals with the finding the maximum separation area between the classes. Right? Now we are going to talk about what are the kernels in SVM. List popular kernels used in SVM along with the scenario of their applications. The function of kernel is to take data as inputs and transform it into a required form. A few popular kernels used in SVMs are as follows, like RVF, linear, sigmoid, polynomial, hyperbolic, Laplace, etc. Now we are going to talk about what is kernel trick in an SVM algorithm. Kernel trick is a mathematical function which, when applied at data points, can find the region of classification between two different classes. Based on the choice of function, be it a linear or radial, which purely depends upon the distribution of data, one can build a classifier. Now we are going to talk about what are ensemble models. Explain how ensemble techniques yield better learning as compared to traditional classification ML's algorithms. Ensemble is a group of models that are used together for prediction both in classification and regression class. Ensemble learning helps improve ML results because it combines several models. By doing so, it allows a better predictive performance compared to a single model. They are superior to individual models as they reduce variance, average out bias, and have lesser chance of overfitting. Now we are going to talk about the 48th question. What are overfitting and underfitting? Why does the decision tree algorithm suffer often with overfitting problem? Wait, let me give you the examples and the answer. Overfitting is a statistical model or machine learning algorithm which captures the noise of the data. Underfitting is a model or machine learning algorithm which does not feed the data well enough and occurs if the model or algorithm shows low variance but high bias. In decision tree, overfitting occurs when the tree is designed to perfectly fill all samples in a training dataset. This results in branches with strict rules or sparse data and affect the accuracy when predicting samples that are in part of the training set. Now we are going to let's see what else we have in our next question for interview. Now we are going to talk about what is OOB error and how does it occur. For each bootstrap sample, there is 1/3 of the data that was not used in the creation of the tree. It was out of sample. This data is referred to as out of bag data. In order to get an unbiased measure of the accuracy of the model over test data, out of bag error is used. The out of bag data is passed for each tree is passed through that tree and the outputs are aggregated to give out of bag error. This percentage error is quite effective in estimating the error in the testing set and does not require further cross-validation. Now we are going to talk about why boosting is more stable algorithm as compared to other ensemble algorithms. So, boosting focuses on errors found in previous iteration until they become obsolete. Whereas in bagging, there is no corrective loop. This is why boosting is a more stable algorithm compared to other ensemble algorithms. Now, we are going to talk about how to handle outliers in the data. Outlier is an observation in the data set that is far away from other observations in the data set. We can discover outliers using tools and functions like boxplot, catapult, z-score, IQR score, etc. and then handle them based on the visualization we have got. To handle outliers, we can cap at some threshold, use transformation to reduce skewness of the data, and remove outliers if they are anomalies or errors. So this is how you can handle outliers in your data. Now, we are going to talk about least popular cross-validation technique. So there are mainly 6 types of cross-validation techniques are there. As follows: k-fold cross-validation technique, stratified k-fold, leave one out, bootstrapping, random search CV and grid search CV. Now we are going to talk about, is it possible to test for the probability of improving model accuracy without cross-validation techniques? If yes, please explain. Yes, it is possible to test for the probability of improving model accuracy without cross-validation techniques. We can do so by running the ML model, that is a machine learning model, for say n number of iteration recording the accuracy. Plot all the accuracies and remove the 5% of low probability values. Measure the left cutoff and right cutoff. With the remaining 95% confidence, we can say that the model can go as low or as high as mentioned within cutoff points. Now, we are going to talk about name of popular dimensionality reduction algorithm. Popular dimensionality reduction algorithms are PCA, that is known as Principal Component Analysis, and Factor Analysis. So, Principal Component Analysis creates one or more index variables for a larger set of measured variables. Factor analysis is a model of the measurement of a latent variable. This latent variable cannot be measured with a single variables and is seen through a relationship it causes in a set of y variables. Now, we are going to talk about how can we use a dataset without the target variable into supervised learning algorithms. Input the dataset into a clustering algorithm, generate optimal clusters. Label the clusters numbers as the new target variable. Now, the dataset has independent and target variables present. This ensures that the dataset is ready to be used in supervised learning algorithm. Now we are going to talk about how do you deal with the sparsity issues in recommendation system and how do we measure its effectiveness. Explain. Singular value decomposition can be used to generate the prediction matrix. RMSE, roots mean square error, is the measure that help us understand how close the prediction matrix is to the original matrix. Now we are going to talk about name and define techniques used to find similarities in the recommendation system. So Pearson correlation and cosine correlations are techniques used to find similarities in recommendation system. Now we are going to talk about explain the term instance-based learning. Instance-based learning is a set of procedures for regression and classification which produce a class-level prediction based on resemblance to its nearest neighbors in the training dataset. This algorithms just collects all the data and get an answer when required or queried. In simple words, they are a set of procedures for solving new problems based on the solution of already solved problems in the past, which are similar to the current problem. Now we are going to talk about keeping train and test splits criteria in mind. Is it good to perform scaling before the split or after the split? Scaling should be done post-train and test split ideally. If the data is closely packed, then scaling post or pre-splits should not make much difference. Now we are going to talk about what is bias theorem. State at least one use case with respect to the machine learning concepts. So bias theorem describes the probability of an event based on prior knowledge of condition that might be related to the event. For example, if cancer is related to age, then using bias theorem, a person's age can be used to more accurately assess the probability that they have cancer than that can be done without the knowledge of the person's age. Chain rule for bias probability or the chain rule for Bayesian probability can be used to predict the likelihood of the next word in the sentence. Now we are going to talk about what is naive Bayes. Why is it naive? Naive Bayes classifier are a series of classification algorithms that are based on Bayes theorem. This family of algorithms shares a common principle which treats every pair of features independently while being classified. Naive Bayes is considered naive because the attribute in it for the class is independent of others in the same class. This lack of dependence between the two attributes of the same class creates the quality of naiveness. Now we are going to talk about explain the difference between lasso and reach. So lasso, that is L1, and reach, that is known as L2, are the regularization techniques where we penalize the coefficients to find the optimum solution. In reach, the penalty function is defined by the sum of the squares of the coefficients, and for the lasso, we penalize the sum of the absolute value of the coefficient. Another type of regulation method is elastic net. It is a hybrid penalization function of both lasso and reach. Now we are going to talk about what's the difference between probability and likelihood. Probability is the measure of the likelihood that an event will occur, that is, what is the certainty that a specific event will occur, whereas a likelihood function is a function of parameters within the parameter space that describes the probability of obtaining the observed data. So the fundamental difference is probability attaches to possible result, likelihood attaches to hypothesis. Now we are going to talk about why would you prune your tree. In the context of data science or AI/ML, pruning refers to the process of reducing redundant branches of a decision tree. Decision trees are prone to overfitting. Pruning the tree helps to reduce the size and minimize the chances of overfitting. Pruning involves turning branches of a decision tree into leaf nodes and removing the leaf nodes from the original branch. It serves as a tool to perform the trade-off. Now we are going to talk about list the advantages and limitations of temporal difference learning method. The temporal difference learning method is a mix of Monte Carlo's method and dynamic programming method. Some of the advantages of this method include it can learn in every step online or offline. It can learn from a sequence which is not complete as well. It can work in continuous environments. Also, it has lower variance compared to MC method and is more efficient than MC method. Right? Limitations of TD methods are, that is temporal difference method, are it is biased estimation. It is more sensitive to initialization. Now we are going to talk about differentiate between statistical modeling and machine learning. Machine learning models are about making accurate prediction about the situations like footfall in restaurants, stock price detection, whereas statistical models are designed for inference about the relationship between variables as what drives the sales in a restaurant, is it food or ambience, right? So this is the main difference between statistical modeling and machine learning. Now we are going to talk about what is the significance of gamma and regularization in SVM. The gamma defines influence, low values meaning far and high values meaning close. If gamma is too large, the radius of the area of influence of the support vectors only includes the support vector itself, and no amount of regularization with C will be able to prevent overfitting. If gamma is very small, the model is too constrained and cannot capture the complexity of the data. The regularization parameter, which is lambda, serves as a degree of importance that is given to misclassifications. This can be used to draw the trade-off with overfitting. Now, we are going to talk about define ROC curve work. The graphical representation of the contrast between true positive rates and the false positive rate at various thresholds is known as ROC curve. It is used as a proxy for the trade-off between true positive versus the false positives. Now, we are going to talk about what is the difference between a generative and discriminative model. A generative model learns the different categories of data. On the other hand, a discriminative model will only learn the distinctions between different categories of data. Discriminative models perform much better than the generative model when it comes to classification tasks. Now we are going to have a look at what are hyperparameters and how they are different from parameters, right? So let's have a look at that. A parameters is a variable that is internal to the model and whose value is estimated from the training data. They are often saved as a part of the learned model. Example include weights, bias, etc. A hyperparameter is a variable that is external to the model whose value cannot be estimated from the data. They are often used to estimate model parameters. The choice of parameter is sensitive to implementations. Examples include learning rate, hidden layers, etc. Now we are going to talk about describe the hash table. Hashing is a technique for identifying unique objects from a group of similar objects. Hash function are large keys converted into small keys in hashing techniques. The values of hash functions are stored in data structure which are known hash table. Now we are going to talk about you have to train a 12 GB dataset using a neural network with a machine which has only 3 GB RAM. How do you go about this? We can use NumPy arrays to solve this issue. Load all the data into an array in NumPy arrays have a property to map the complete dataset without loading it completely in memory. We can pass the index of the array, dividing data into batches to get the data required and then pass the data into the neural networks. But be careful about keeping the batch size normal. Now we are going to talk about write a simple code to binaries data. Yes, I will give you the example as well. How can you write the simple code to binaries the data? Conversion of data into binary values on the basis of certain threshold is known as binarizing of data. Values below the threshold are set to 0 and those above the threshold are set to 1, which is useful for feature engineering. Now let's have a look at the coding itself. So first we are going to import from sklearn.preprocessing import binarizer. Now we are going to import pandas and NumPy. Then we will have our names list that Alashka, Pratyush, Piers, Sandra, like this, and then we are going to make a data frame that pandas.readcsv and we are going to use the URL and names equals to we are going to use the names list. Now array is equals to data frame dot values. In the array you will have all the values. Now splitting the array into input and output. Now we are going to split the array into the two parts. One is input, one is output. A is equals to array. You are splitting the array for A and B both. Now you are going to use a variable called binarizer equals to you are calling the binarizer object and where threshold equals to 0.0 and you are training your model using X, right? Now binary A is equals to binary dot transform A and then numpy dot set print options precision equals to 5. Then print binary that A part, right? So this is how you can binarize your data. It's a very simple code. Now we are going to talk about what is an array. The array is defined as collection of similar items. stored in a contiguous manner. Array is an intuitive concept as the need to group similar objects together arises in our day-to-day lives. Arrays satisfy the same need. How are they stored in the memory? Arrays consume blocks of data, whereas each element in the array consumes one unit of the memory. The size of the unit depends on the type of data being used. For example, if the data types of the element of the array is in int, then 4 bytes of the data will be used to store each element. For character data types, 1 byte will be used. This is implementation specific, and the above units may change from computer to computer. Example, you are having a list that is fruits equals to apple, banana, pineapple. In the above case, fruit is a list that comprises of 3 fruits. To access them individually, we use their indexes. Python and C are zero index language. That is, the first index is 0. MATLAB, on the contrary, starts from 1, and thus it's a one index language, right? So this is the thing you need to keep in your mind, that Python and C is a zero index language, whereas MATLAB is a one index language, right? Now we are going to talk about explain eigenvector and eigenvalue. Linear transformations are helpful to understand using eigenvectors. They find their prime uses in the creation of covariance and the correlation matrix in the data science. Simple put, eigenvectors are directional entities along which linear transformation features like compression, flip, etc. can be applied. Eigenvalues are the magnitude of the linear transformation features along each direction of an eigenvector. Now we are going to talk about how would you define the number of clusters in a clustering algorithm. The number of clusters can be determined by finding the silhouette score. Often we aim to get some inferences from the data using clustering techniques so that we can have a broader picture of a number of classes being represented by the data. In this case, the silhouette score helps us determine the number of cluster centuries to cluster our data along. Another technique that can be used is the elbow method. Now we are going to talk about what are the performance metrics that can be used to estimate the efficiency of a linear regression model. The performance metric that is used in the cases mean squared error, R-squared, adjusted R-squared, and mean absolute score. Now we are going to talk about what is default method of splitting in decision tree. The default method of splitting in decision tree is the Gini index. Gini index is the measure of impurity of a particular node. This can be changed by making changes to classifier parameters. Now we are going to talk about how is p-value useful. The p-value gives the probability of the null hypothesis is true. It gives us the statistical significance of our results. In other words, p-value determines the confidence of a model in a particular output. Now we are going to talk about, can logistic regression be used for classes more than 2? No, logistic regression cannot be used for classes more than 2 as it is a binary classifier. For multi-class classification, algorithms like decision tree, naive Bayes classifier are better suited. Now we are going to talk about what are the hyperparameters of a logistic regression model. Classifier penalty, classifier solver, and classifier C are the trainable hyperparameters of a logistic regression classifier. This can be specified exclusively with values in grid search to hyper-tune a logistic classifier. Now we are going to talk about name a few hyperparameters of decision tree. The most important features which one can tune in decision tree are splitting criteria, mean leaves, mean samples, and max depth. Now we are going to talk about how to deal with multicollinearity. Multicollinearity can be dealt with by the following steps. Remove highly correlated predictors from the model. Use partial least square regression that is known as PLS or principal component analysis technique that is PCA. So now we are going to talk about what is heteroscedasticity. It is a situation in which the variance of a variable is unequal across the range of values of the predictor values or the predictor variable. It should be avoided in regression as it introduces unnecessary variance. Now we are going to talk about, is ARIMA model a good fit for every time series problem? No. ARIMA model is not suitable for every type of time series problem. There are situations where ARIMA model, that is, there is a two type of model and there are lots of model we have as well. Whereas some cases ARIMA model and the other also come in handy. ARIMA is the best when different standard temporal structure required to be captured for time series data. Now we are going to talk about how do you deal with the class imbalance in a classification problem. Class imbalance can be dealt with the following ways: using class weights, using sampling, using smooth, choosing loss function like focal loss, right? So these are the ways to deal with the imbalance in a classification problem. Now we are going to talk about what is the role of cross validation. Cross-validation is a technique which is used to increase the performance of a machine learning algorithm, where the machine is fed sample data out of the same data for a few times. The sampling is done so that the dataset is broken into small parts of the equal number of rows, and a random part is chosen as a test part or a test set, while all other parts are chosen as trained sets. Now we are going to talk about what is voting model. A voting model is an ensemble model which combines several classifiers, but to produce the final result in a case of classification based model takes into account the classification of a certain data point of all the models and takes the most vouched or voted or generated option from all the given classes in the target column. Now we are going to talk about how to deal with very few samples, right? Very few data samples, right? Is it possible to make a model out of it? It's a very few samples or the data samples are there. We can make use of oversampling to produce new data points. In this way, we can have new data points. What are the hyperparameters of an SVM? The gamma value, C value, and the type of kernel are the hyperparameters of an SVM model. Now we are going to talk about what is pandas profiling. Pandas profiling is a step to find the effective number of usable data. It gives us the statistics of null values and the usable values and thus makes variable selection and data selection for building models in the pre-processing phase very effective. Now we are going to talk about what impact does correlation have on PCA. If data is correlated, PCA does not work well. Because of the correlation of variables, the effective variance of variable decreases. Hence, correlated data when used for PCA does not work well. Now we are going to talk about how PCA differentiates from LDA. PCA is unsupervised whereas LDA is also unsupervised. PCA takes into consideration the variance, the LDA takes into account the distribution of classes. So this is where PCA is different from LDA. Now we are going to talk about what distance matrix can be used in KNN. So following the distance matrices can be used in KNN like Manhattan, Minkowski, Tanimoto, Zackert and etc. Right? Now we are going to talk about which metrics can be used to measure correlation of categorical data. Chi-square test can be used for doing so. It gives the measure of correlation between categorical predictors. Now we are going to talk about which algorithm can be used in value imputation in both categorical and continuous categories of data. KNN is the only algorithm that can be used for imputation of both categorical and continuous variables. Now we are going to talk about when should ridge regression be preferred over lasso. We should use ridge regression when we want to use all predictors and not remove any, as it reduces the coefficient values but does not nullify them. So this is the reason when you should go for ridge regression and this is preferred over lasso. Now we are going to talk about which algorithm can be used for important variable selection. Random forest, XGBoost and plot variable importance charts can be used for variable selection. Now we are going to talk about what ensemble technique is used by random forests. Batting is the technique used by random forest. Random forests are a collection of trees which work on sample data from the original dataset, with the final prediction being a voted average of all trees. Now we are going to talk about what ensemble technique is used by gradient descent or gradient boosting trees. Boosting trees is a technique used by GBM. Now we are going to talk about which type of sampling is better for a classification model and why. Stratified sampling is better in case of classification problems because it takes into account the balance of classes in train and test sets. The proportion of class is maintained and hence the model performance better. In case of random sampling of data, the data is divided into two parts without taking into consideration the balanced classes in the train and test sets. Hence, some class might be present only in train sets or validation sets. Hence, the result of the resulting model are poor in the case. So, we almost came to the 96th question, that when can be a categorical value treated as continuous variable and what effect does it have when done so? A categorical predictor can be treated as a continuous one when the nature of data points it represents is ordinal. If the predictor variable is having ordinal data, then it can be treated as continuous, and conclusion in the model increase the performance of the model. Now we are going to talk about what is the role of maximum likelihood in logistic regression. The maximum likelihood equation helps in estimation of most preferable or probable values of the estimator's predictor variable coefficient, which produce results which are the most likely or most probable are quite close to the truth values. Now we are going to talk about which distance do we measure in the case of KNN. The Hamming distance is measured in case of KNN for the determination of nearest neighbors. K-means uses Euclidean distance as well. Now we are going to talk about what is pipeline. A pipeline is a sophisticated way of writing software such that each indent action while building a model can be serialized, and the process called the individual function for the individual task. The tasks are carried out in a sequence for a given sequence of data points, and the entire process can be run onto n threads by use of composite estimators and scikit-learn. Now we are going to talk about what is a good metric for measuring the level of multicollinearity. VIF or 1 by tolerance is a good measure of measuring multicollinearity in models. VIF is the percentage of the variance of a predictor which remains unaffected by other predictors. So higher the VIF or this VIF value, greater is the multicollinearity amongst the predictors. A rule of thumb is interpreting the variance inflation factor. 1 is equals to not correlated. Between 1 to 5 equals to moderately correlated, whereas greater than 5 is equals to highly correlated. So in this tutorial, we have a look at what is machine learning, why do we need machine learning, and what the types of machine learning we have. Also, we have covered almost 100 questions in machine learning interview. So if you are an enthusiast as well, if you want to go for and sit for machine learning interview, then I should suggest you should go for the full tutorial. It will help you to have an understanding what are the basic questions you need to be very clear whenever you go for any interview. And please do let us know in the comment section what do you think about this video. And before I complete the video, let me introduce that Great Learning has come up with the brilliant idea that is Great Learning Academy, where you will get almost 80 plus free courses, and after completing your course you can claim your certificate as well. And if you want to do these courses in your mobile application, that is also possible using Great Learning app. Thank you so much.